Welcome to the mini project designed for the AINT 513 Visual Perception and Autonomy module. For this project, I have created a face detection system using Haar Cascades and face recognition systems with Eigenface, Fisherface, and local binary pattern histograms. The aim of the project is analyzing the robustness of each algorithm by implementing them using OpenCV and Python. In the following videos, I will demonstrate the different vision systems I have designed for face detection and face recognition. Furthermore, I will show the applications and the process I followed for capturing images for the dataset and training the algorithms. Finally, I will describe and demonstrate the applications I have designed for determining the best parameters for the three face recognition algorithms. I have the starting times of each of these in the video description below, and all the files in this video are in a Git repository, and I have the link in the description as well. This application is designed to detect faces using Haar Cascades. First, it imports OpenCV library and the functions I have designed to draw a marker around the detected face. Next, it creates two cascade classifier objects, one for the face and one for the eyes. This function, detect multiscale, detects the faces in a given image and returns the locations. In these loops, eyes are detected in the same way. So, if there is a face and in that face there are eyes, this command draws a marker around the location taken from the face cascade. Let's see the results. You can see it detects my face even when I turn my head slightly. If I cover my eyes, it's not going to detect the face because it needs to see the eyes for it to understand that it's a face. Okay, let's check the face recognition. I designed this application to recognize detected faces using Eigenface algorithm. Eigenface uses principal component analysis to extract features from a set of faces and classify them, resulting a set of vectors called Eigenfaces. By projecting a new face and comparing with the saved Eigenfaces, the application can find the similarities and identify the face. Other than the face detection code, there is a face recognizer object with 15 components and a threshold of 4000. In next line, the program loads the saved Eigenface XML file. I will show how I created these XML files later. When the face is detected and cropped, it is passed to the face recognizer object, which would return an ID and a confidence level. Although OpenCV calls it a confidence value, it is the distance the detected face has to the class that the ID belongs to. This function finds the name from a lookup table using the ID and concatenate with the confidence value. This function draw a marker and show the concatenated string on the screen. Let's see the results. Okay, Eigenface seems to be working fine. You can see it identifies me perfectly, and the threshold set over here is 4000. If it's above that, it will say face not recognized. Let's take a look at Fisherface now. This application recognizes detected faces using Fisherface algorithm. Fisherface uses linear discriminant analysis instead of PCA. While principal component analysis is used to represent faces, LDA can be a better classifier. When applied to a set of images, the resulting basis vectors defining that space are known as Fisherfaces. The application is almost similar to the Eigenface application, but the number of components and the thresholds are different. The components are 5 and the threshold is 600. I will show how I came up with these parameters later. The rest of the application is similar to the Eigenface, so let's see the results. Okay. Looks like it's working fine. The threshold is set to around 600. This application recognized detected faces using local binary pattern histogram. Local binary pattern is simple but a very efficient system to identify textures. It can label the pixels of an image by thresholding the neighborhood of each pixel and return the result as a binary number. LBPH has many advantages. For example, it does not depend on the illumination levels like other algorithms. The application is similar to the last two. The recognizer object is created with 2 pixels of radius, 2 neighbors, and 7 by 7 cells. I have set the threshold to 15, which is much lower than the other 2 algorithms. The rest of the application is similar to the previous 2. Let's see the results. I have set the threshold to 15. So far it looks like it's doing a good job. Now, about detecting multiple faces, I will try to get other people to come here and see if it can detect them as well. Okay. The purpose of this video is to show that the threshold works, and since Sebastian's face is not in the dataset, it should assign unknown for him while printing my name correctly.
Probably not.
It can recognize my face, but Seb's face is not recognized, and we are using the threshold 4000. This is the application I wrote to capture new images for the dataset. In the first lines, it imports the Haar Cascades required for face detection. In the next line, the application asks for a name and save the name to a text file. This is a counter to count the number of photos saved. This if condition verifies the averaged pixel values in the image are above a certain threshold to proceed. This function takes the image and finds the location of the eyes. If they are at an angle to the x-axis, the function rotates the whole face to correct the offset. I include these 2 functions after noticing the poor performance in Eigenface because of dark and crooked photos in the dataset. And so, if all these conditions are satisfied, this line saves the image with an ID and pause for 300 milliseconds to start the next loop. Let us see the results. Type in a name. Now the person needs to look slightly to left and right while up, down, smile, frown, look at the camera. Basically you do all sort of different expressions, so the dataset will have a very good range of motion. I designed this application to train the 3 algorithms at the same time. First, I create 3 face recognition objects using required parameters. This function imports the images in the dataset one by one, saving them in a numpy array and then in a list. It also stores the IDs in another list. After all the images are saved, each face recognizer is trained with the image list and the ID list. After training, the XML files are saved as well. It should train them fairly quickly. These are the images in the dataset. This last photo was taken before I wrote the code to correct the tilt. Okay, you can see Eigenface is saved, Fisherface, and local binary pattern histogram. To find the best value for each algorithm, I have designed 3 applications. They will train the face recognizer objects over and over with different parameters while recording the outputs. In the first half, the code is similar to the trainer, except I have imported the plotting library as well. From this point, it changes. Face detection happens in this line and the face is cropped. 2 lists are initialized for ID and the confidence values. This loop will run for 200 times, each time incrementing the number of components in the create Eigenface recognizer object. Each time it is tested against the given face, recording the ID and the confidence level. After the 200th loop is done, it will create two plots, one for the ID and one for the confidence level. This line will print out the time it took to execute all the commands. It also shows the face that it tested at the end. Let's see how it runs. We can see the two plots and the face it tested. The ID is steady between 20 and 21. Both IDs are mine since I stored two sets of images, and confidence level keeps increasing, which means the results are becoming more and more uncertain. Looking at these values, I think the best number of components can be around 15, and the threshold is around 3,500 to 4,000. Furthermore, it took 43 minutes and 11 minutes to run this program. The Fisherface tester is almost the same, so I will show the resulting plots from it. The ID fluctuates at the beginning and stays steady till the end. Also notice as the ID is fluctuating, the confidence level reaches 800 and stays steady. Just to make sure, I will run another photo. These are the plots for Sam's photo. His ID in the application is 17, so the system did identify his face correctly. The maximum confidence value is 1074 and is steady at 8 components. From these data, I would say the best number of components would be around 2 to 3, and you can set the threshold to 400. This application is the tester for the LBPH algorithm. Unlike the previous two, LBPH takes in 5 parameters including the threshold. The first parameter is the radius, and it can have a maximum value of 54. When the loop finishes, the application will display the plots and ask the user to type in the most suitable radius for the next loop. In the next loop, the number of neighbors will be iterated, and it can go up to 13. As before, when the loop finishes, it will ask for the ideal number of neighbors. In the final loop, the number of cells in the X and Y axes are changed. Finally, all 6 plots are displayed on screen and the user can make his final decision. We can see the first 2 plots now. I would say the best value would be 1 pixel radius. We got the second set. The ID is steady and we can get a low confidence at 1 neighbor. Let's enter it and see what happens. On this screen we can see all the 6 plots. Look how low the confidence is in the last plot. I would say if we set 1 pixel and 1 neighbor and around 7 by 7 cells, we are able to set a threshold of 15 to 20. Thank you for watching this video demonstration of face detection and face recognition.